I'm Tim. This PCB Sync.
This episode is hands-on content aimed at engineers. We will combine official Rogers materials with an open source 5.8 GRF PCB project to clearly explain RO4003C's Stackup impedance drilling via metallization and hybrid lamination design. If your project is ready for production, it's best to clarify these issues before sending the Gerber files to the PCB manufacturer. Let's take a look at the data sheet first. Starting with the Stackup, RO4003 has a process dielectric constant of 3.38 with a tolerance of plus or minus 0.05. When used for transmission line dimension and impedance calculations, Rogers specifies a design dielectric constant of 3.5. So you can't simply substitute 3.38 directly into all impedance calculations during design. A more reliable approach is to first use the design DK for modeling based on the target frequency, structure, and board thickness, and then confirm the actual stack-up and impedance compensation with the board manufacturer. The common standard core thicknesses for RO4003 include 0.203, 0.305, 0.406, 0.508, 0.813, and 1.524 mm. After determining the board thickness, you also need to include the copper thickness, impedance layer, and final laminated thickness in the impedance model. On the screen is an open source distributed phase shifter operating at 5.8 GHz. Here you can see TL1 to TL4. They are not ordinary traces, but part of the RF circuit. Their width affects the impedance, while their length affects the electrical length and phase. Impedance control is not just about giving the board manufacturer a 50 ohm requirement. The design files should also clearly specify the allowable impedance tolerance, the layer where the trace is located, the reference layer, dielectric thickness, copper thickness, and whether it is a microstrip, strip line, or coplanar structure. At high frequencies, etching compensation and the finished copper thickness will also change the actual trace width. During the design phase, a field solver can be used to determine the initial values, but before mass production, the board manufacturer should recalculate based on the actual materials and processes. In terms of the manufacturing and fabrication side of things, let's take a closer look at the official processing manual. One key practical advantage of using RO4003 is that it is fully and easily compatible with many common standard FR4 production processes used throughout the industry today. The Rogers Processing Guide also states that this type of material can use the common FR4 developing, etching, and stripping systems, but the drilling parameters cannot be directly copied from FR4. The guide recommends using standard alloy drill bits with a surface speed of 300 to 500 SFM and a typical tool life reference of 2,000 to 3,000 holes per bit. Because the material contains ceramic fillers, drill bit wear may occur more quickly, so the actual tool change frequency should be determined by the quality of the metallized hole edges, not by the appearance of the tool. In terms of hole metallization, RO4003C does not require any special treatment before metallization. It is compatible with both electroless copper and direct metallization processes. This is different from some PTFE materials that require special hole wall treatment, and is one of the reasons why RO4003C is relatively easy to process. RO4003 is suitable for multi-layer board structures and can also be combined with other materials to form hybrid dielectric layers according to project requirements. When designing hybrid laminates, don't just consider if materials can be pressed together. You must also confirm lamination temperature, resin flow, copper adhesion, dielectric tolerance, and thermal expansion differences. The CTE, coefficient of thermal expansion, of RO4003C in the X, Y, and Z directions is 11, 14, and 46 ppm per degree Celsius respectively. This is especially important for thick boards, high aspect ratio holes, and structures that undergo multiple laminations, where you should pay particular attention to how this expansion affects the copper vias. In terms of surface finish, the official documentation states that it is compatible with OSP, HSL, and various types of chemical or electroplated surface treatments. For RF traces, you can't simply assume that a deposited finish is always better. The thickness of the surface finish, surface smoothness, and conductor loss will all affect high-frequency performance. Ultimately, you should consider frequency, soldering requirements, storage cycle, and cost, and try to avoid adding unnecessary base thickness to critical RF traces. There are 5 common mistakes in RO4003C design. First, using a dielectric constant of 3.38 to calculate all transmission lines directly, without distinguishing between the manufactured DK and the design DK. Second, after changing the material or board thickness, only adjusting the trace width without rechecking the electrical length and phase. Third, specifying an impedance requirement of exactly 50 ohms without mentioning the reference layer, structure, or tolerance. Fourth, assuming that since the processing method is similar to FR4, the drilling and compensation parameters for FR4 can be copied directly. Fifth, in hybrid stack-up designs, only focusing on electrical performance without confirming lamination CTE and via copper reliability in advance. These issues can be identified through stack-up evaluation and DFM review before mass production, resulting in low modification costs. In short, RO4003 is more processable than PTFE alternatives, but key challenges remain in stack-up, impedance, dimensional compensation, and supply stability. When designing, use the correct design DK, and before production confirm the actual material copper thickness, finished board thickness, and impedance compensation. Only then can you reduce the risk of frequency deviation or poor impedance in the first prototype. If you are designing a high-frequency printed circuit board with RO4003C printed circuit board, SENIC can assist with layer evaluation, impedance design, DFM review, prototyping, and mass production. Scan the QR code on the screen and upload your Gerber files to start your inquiry. If you think this